A very good morning to one and all. Now, myself Che Anusha, working as lecturer in physics, and I'm working under Department of Technical Education, Telangana. At present, I'm working at SS Government Polytechnic, Zahirabad, and I'm working in general section. The subject what I'm dealing for first year, second sem students is applied physics. The subject code of this is 18 common 203F. The topic what we are discussing here is electricity and measuring instrument, which is fifth chapter from our syllabus. Now in today's session we are going to learn about specific resistance and conductance with their units. Now to learn this, I am taking help of PowerPoint presentation. The main objective of today's session is, on completion of this period, you will be able to learn what is specific resistance, what is conductance. Now, before moving on to today's session, let us recall what we learned in the previous session. Now, in the last class, we studied about ohmic and non-ohmic conductors, and also we learned about temperature coefficient of resistance. Now, ohmic are the conductors which obey Ohm's law, and non-ohmic conductors are the conductors which does not obey Ohm's law. Now, temperature coefficient of resistance is the resistance of the material depends on the temperature. Now, depending upon this dependence, this coefficient is of two types, positive and negative. For metals or conductors, it is positive, and for semiconductors and insulators, it is negative. Now, what is specific resistance, or which is also known as resistivity? Now, to understand specific resistance or resistivity, the resistance of a conductor depends upon dimension of conductor and material with which it is made, and also it depends on temperature of the conductor. Now, it is found that at constant temperature, the resistance of the conductor is directly proportional to its length and inversely proportional to area of cross section of the conductor. Now, if we write this proportionality, R is proportional to length and R is proportional to 1 by A, as it is inversely proportional, we are considering it as 1 by A. Now, when we combine these two proportionalities, R is proportional to L by A. Now, if we take it out proportionality, we are getting one constant, that is rho. So, R is equals to rho into L by A. Now, this rho is specific resistance or resistivity. Now, see here in the expression, if L is equals to 1 and A is equals to 1, so what is R? That is equals to rho. Now, we can define specific resistance as, it is the resistance of a conductor of unit length and unit area of cross section. Now, what is SI unit of specific resistance? Specific resistance or resistivity is expressed as ohm meter. Now, symbolically it is ohm meter. What is conductance? The reciprocal of resistance is conductance. So, reciprocal is simply conductance is equals to 1 by resistance. Now, what is conductance definition? The ratio of the current passing through a conductor to the potential difference developed across its ends is called conductance of the conductor. Simply it is V by I is equals to R. Reciprocal of R is I by V. That is conductance. Now, unit of conductance is Siemens. Remember this, the unit of conductance is Siemens. I think it is, or simply we can say ohm inverse. Now conductivity or specific conductance. The reciprocal of resistivity is called conductivity or specific conductance. So conductivity sigma, which is equals to 1 by resistivity, that is 1 by rho. The conductivity of the material is defined as conductance of the conductor of unit length having unit area of cross section at constant temperature. Now what is unit of conductivity? The SI unit of conductivity is Siemens per meter. So this is about resistivity or specific resistance. Now this is a very small discussion. We are just learning about only few definitions. They are about specific resistance, specific conductivity. Now as we learned in the previous session about resistance, now this resistance is depending upon length of the conductor and it is depending upon area of cross section of the conductor. The dependence is R is directly proportional to L and R is inversely proportional to A. Now combining these two, we got an expression for specific resistance as R equals to rho into L by A. Now if this L and A are equal to 1, then rho is equals to R. Depending upon this, we define specific resistance as the resistance of a conductor of unit length and unit area of cross section. Now very important expressions. Using this formula, let me write by using this formula, rho is equals to R into A by L. This is very important expression. And its unit ohm meter. Now the reciprocal of resistance is conductance. Unit of conductance is ohm inverse or Siemens. Now the reciprocal of resistivity is conductivity. The unit for this is Siemens per meter. So what we discussed in this session, we have discussed about specific resistance and its unit, conductance and conductivity and their units. Now the reciprocal of specific resistance is specific conductance or conductivity, which is expressed by sigma. The sigma is equals to 1 by rho. Now as I have written the formula or the expression for rho as R into A by L, so reciprocal of that is L by R into A, that is expression for conductivity. So let us see, specific resistance is expressed in ohm, ohm meter, voltmeter, none of the above. It is ohm meter. Next, resistance depends on length, pressure of conductor, length, area of cross section of the conductor, length, area of cross section and temperature of conductor, none of the above. It depends on length, area of cross section and temperature of conductor. What is unit of conductivity? Siemens, Siemens meter, Siemens per meter, none of the above. It is Siemens per meter. Now, what are symbols for resistivity and conductivity? Rho and sigma, ohm and q, ohm and v, none of the above. That is rho and sigma. Now, here are some frequently asked questions. Derive an expression for resistivity of a conductor and state its SI unit. So we derived an expression by using the relation between R and L, R and A, where L is length of the conductor and A is area of cross section of the conductor. Now by using their relations that R is directly proportional to L and R is inversely proportional to area of cross section, we can derive an expression for resistivity and also its SI unit, that is ohm meter. Define conductivity and state unit of conductivity. So with this I am concluding class. Thank you so much for listening it. I hope you are very clear with this topic. We learned about specific resistance, which is also known as resistivity, and also we learned about conductance, which is reciprocal of resistance, and the reciprocal of specific resistance is specific conductance, which is simply reciprocal of resistivity, that is conductivity. So with this I am concluding. Thank you so much for listening class. I hope this class is useful for your learning practice. Thank you so much.
Welcome you all. This video session will give you the complete differences between the electrical resistivity and electrical conductivity. Sometimes these two terms will confuse you while solving the problems. So you should have clear configuration between electrical resistivity and electrical conductivity. Now let us enter into the lesson. Resistance is the specific and important property of a material. This property is the special one which opposes the flow of the current through it. Let us consider the two important factors such as the length of the conductor L and the area of cross section A. These two factors influences the resistance of the material. I'll explain you one by one as follows. Here you are having two conductors with different length, one with larger length, the other one with shorter length. So the electrons passing through the first conductor, which is having the larger length. The electrons should collide with more number of atoms present in the conductor. Electrons of this conductor. So we can conclude that the resistance is more in the first case. These electrons, when passing through the conductor, has to collide with the conductor, so that the possibility of resistance is higher, and hence the resistance R is directly proportional to the length of the conductor. If the length is large, then the resistance is more in the first case. But when you look at the second case, see the electrons how they are colliding with the atoms of the conductor. Because there is less number of atoms present in the conductor of short length, and hence the possibility of colliding with the atoms present in the conductor is also less, and hence we can easily say that the resistance is directly proportional to the length of the conductor. If the length is larger, then the resistance is more. When the length is shorter, the resistance is less. Do you have any experience in crossing a crowd? It is tedious to cross because definitely you have to hit many people, then only you can reach the other end. So resistance is high in this case. In the same way, if you look at the two cross sections of the conductor, the electrons have to collide only less number of times with the atoms present in the first conductor, and in the same way, the number of atoms is more, then the electrons produce many collisions in its path. That is, the resistance is high. Here, you can look at the area which is wider, and hence the electrons has the less possibility to collide with the atoms present in the conductor. The electron has to pass from one end to the another end with many number of collisions because the area is less, and hence if the area is larger, the resistance is less. If the area is lesser, the resistance is more, and hence resistance is inversely proportional to the cross-sectional area. Now it is clear to have this concept. If the area is larger, then the resistance is less. If the area is smaller, then the resistance is high, and hence we can have area of cross-section in the denominator, that is R proportional to 1 by A. You can consolidate the above understanding. R proportional to L, that is the resistance directly proportional to the length of the conductor, and you can keep this as equation number 1, and R proportional to 1 by A, that is the resistance inversely proportional to the area of cross section of the conductor, and you keep this equation as 2, and when you combine these two equations, then you can generally get R directly proportional to L by A. If you want to remove the proportional term, then you have to put a constant, and R is equal to rho into L by A, and this proportionality constant rho is termed as electrical resistivity. This important term as the electrical resistivity of the conductor, and this determines the resistance of the conductor, and this is the number, so it is called as the constant, and this is constant for each and every material. We are always using copper wire to carry current. What may be the reason? Because the resistivity of copper is less, that is 1.72 into 10 to the power of minus 8 ohm meter when you compare with iron. Iron having its resistivity 9.71 into 10 to the power of minus 8 ohm meter. It will produce more heat with the passage of electricity. So copper wire is preferable here. If you want the term rho, then you have to rearrange this equation. Rho is equal to RA by L, and this is the important term which is termed as the electrical resistivity. Nichrome is a conductor with highest resistivity equal to 1.5 to the power of minus 6 ohm meter. So it is used in making heating elements. Now let us define what is electrical resistivity in proper terms. Electrical resistivity of a conductor is a measure of the resisting power of a specified material to the passage of an electric current. And we know each and every material provides some resistance for the passage of the electrons. And it is specified in a specific number. It is called as the electrical resistivity. And it is a constant term, and it is also a constant for a given material. Conductors are materials which allows readily electrons to pass through, and insulators resist the passage of the electrons. But the resistivity is less for conductors and more for insulators. Unit for electrical resistivity is ohm meter. Remember that the electrical resistivity is denoted by the letter rho, and rho is equal to RA by L. Now let us switch over to electrical conductivity. Before that, we have to know what is conductance. Conductance of a material is the property to aid the flow of the charges, and the conductance of a material is mathematically defined as the reciprocal of its resistance. We know R is the resistance, and conductance is denoted by the letter capital G. Capital G is equal to 1 by R. Conductance capital G is equal to 1 by R. Here R is the resistance. Conductivity can be defined as the reciprocal of the electrical resistivity, and sigma is equal to 1 by rho. Here sigma is electrical conductivity and rho is the electrical resistivity. Be familiar with unit of the conductivity. Ohm power minus 1, meter power minus 1. Sometimes ohm power minus 1 can be written as mho, meter power minus 1. And also in symbol we can write it as ohm power minus 1 and meter power minus 1. This is the unit of the conductivity. Conductivity can be defined in alternative terms as follows. Electrical conductivity of a conductor is a measure of its ability to pass the current through it. You can easily understand this concept with the following example. Look at the conductor here. The electrons are moving freely inside the conductor. This conductor provides only less resistance to the flow of the electric current.
Resistance and resistivity. We will explain in detail about the resistance and the resistivity, and we will differentiate between the resistance and resistivity. Okay, let's explain the resistance first. Resistance is the position that a substance offers to the flow of electric current. The symbol of resistance is R and the SI unit of resistance is ohm, which is denoted by this symbol. And according to the Ohm's law, we know that voltage V is equal to IR. The voltage is equal to current time resistance. And from this equation, we can derive that R resistance is equal to V divided by I. V is the voltage and I is the current. If V is equal to 1 and I is equal to 1, we will get 1 ohm, which will be the value of the resistance. Now, resistance depends upon the dimensions of a wire. For example, if we have this wire, the length of this wire is L, and the area of this wire, this cross-sectional area of the wire A. Now, the resistance is directly proportional to the length, and this resistance will be inversely proportional to the area. Combining these two equations, we will get resistance R is equal to rho into L by A, and this rho, this term is known as resistivity. Resistivity is actually the constant of proportionality. Now, resistivity is a fundamental property of a material that qualifies how strongly it resists or conduct the flow of electric current. The resistivity from this equation can be derived as rho is equal to R into A divided by L. For example, we have this wire. Now, this area, this is the cross-sectional area A, and this is the length of this wire. If we have this cross-sectional area equal to 1 meter square and the length of this wire is equal to 1 meter, then we will have resistivity is equal to resistance. Now, different materials have different values of resistivity. For silver, this is 1.59 multiplied 10 power minus 8. Similarly for copper, this is for annealed copper, and for gold and aluminum.